Electricity is essential to modern life, both at home and on the job. As a source of power, electricity is accepted without much thought to the hazards encountered. Perhaps because it has become such a familiar part of our surroundings, it often is not treated with the respect it deserves. To handle electricity safely, you need to understand how electricity acts, how it can be approached, and the hazards it presents. You also need to know how these hazards can be controlled. Learn as much as you can and use this program as the beginning, not the end of your training in electrical safety. Deaths from electrical shock and electrocutions are being reduced. That's the good news, and perhaps it's because we're learning to live with electricity, even though it can be dangerous. In the workplace, people other than electricians generally do not work on electrical equipment or energized electrical parts. That's the job of people who are trained and authorized to work with electricity. So why do we need a training program on electrical safety? The answer is quite simple. Although deaths are down, there are still many thousands of serious electrical injuries each year that don't result in death. Burned hands, feet, and bodies. There are literally thousands of electrical fires and a very large number of accidents and injuries. The solution is for everyone to know more about electricity and safety measures. We certainly don't intend to cover all aspects of electrical safety. It's your company's responsibility to provide proper training and procedures for working with and using electricity. The National Electrical Code is the foundation for all state and local codes. But more restrictive measures may be imposed at the city or county levels. All electrical work and wiring must meet the National Electrical Code standards. Always follow your company's policies and procedures. The primary hazards of electricity include shock, burns, arc blast, explosions, and fires. You can get a shock when some part of your body becomes part of an electrical circuit. An electric current can enter the body at one point, such as your hand, and exit the body at another location, such as your foot. High voltage shocks can cause serious injuries, especially burns and/or death. You'll get a shock if you touch both wires of an electrical circuit or one wire of an energized circuit and ground. You can get shocked if you touch part of a machine that is energized because it is contacting a hot wire and ground. An arc blast can occur when high amperage currents jump from one conductor to another through air, generally during opening or closing circuits. This can happen also when static electricity is discharged. Fire may occur if the arcing takes place in an atmosphere that contains flammable liquids or an explosive mixture of gas. Electrical fires occur quite frequently. Heat develops in an electrical conductor from the flow of current. The more resistance, the higher the heat. So a short circuit, older wire, or other factors can cause greater resistance in the circuit. Circuits conducting a high rate of current and generating more resistance than it can handle can create enough heat to cause a fire. Electricity doesn't like resistance, so it flows through the path of least resistance. Plastic, glass, and rubber are poor conductors of electricity, so these products are generally used as insulators to prevent the flow of electricity. Pure water is a poor conductor, but with small amounts of impurities such as salt and acid make it an excellent conductor. Dry wood is a poor conductor, but if the wood is wet, it becomes a great conductor. Obviously, electricity is harmful to your body, so you never want to give electricity the choice of going through your body. Shock occurs when the body becomes part of an energized electrical path and energy is transferred between parts of the body or through the body to a ground or the earth. The resistance of the body and the degree to which the skin is insulated from the ground govern the amount of current flowing through the body. The skin offers the principal resistance, which the human body presents to the flow of current. If the skin is wet or moist, then the resistance is lowered. Both the magnitude and path of the current flowing through the body are of primary importance. When the path of the current is hand to foot or hand to hand, vital organs such as brain, heart, lungs, and spinal cord are affected, usually with very serious consequences. The age and physical and emotional condition of the person involved can also affect the severity of an electrical shock. Of course, everyone working with electricity should know CPR and appropriate emergency action procedures in case of electrical shock. Everyone working around and using electricity should report any shock received, no matter how slight. Report any popping or sparking because this means something is wrong. Report noticeable defects or hazardous conditions so they can be corrected. We're not going to list all the lightning safety rules, but we did want to dispel a couple of lightning-associated myths. First, you're safe in your automobile if lightning strikes because the tires are rubber and act as insulation. No, that's not correct. Actually, in strong electrical fields such as lightning, rubber tires become more conductive than insulating. The reason you are safe in your car is because lightning will travel around the surface of the vehicle and then to ground. The metal is a good conductor and would direct the current around the vehicle and discharge safely to the ground. Is it true that the tallest of buildings get struck by lightning? Taller objects are closer to the clouds, but lightning can strike the ground at a close distance away from a tall object. Taller objects may have a higher possibility of a strike, but lightning is unpredictable, and you just never can tell where it's going to strike. Surge protectors will definitely not protect your equipment from lightning strikes to power lines. They're called surge protectors because they protect from minor power surges on the power line, but not lightning strikes. During electrical storms, always unplug electrical equipment and never use the telephone or fax. There have been many deaths from people using telephones when lightning strikes the telephone line. Electricity requires special wiring systems. In order for electricity to flow, you must have a completed circuit, and it is based upon the law of physics that electricity flows to the path of least resistance. We learned that if electricity has a choice of a metal conductor or your body, it would prefer to flow through the metal conductor. Okay, when electricians wire offices, plant facilities, and equipment, they generally use 3 wires. One wire is the neutral, one is the hot, and one is the ground. In the workplace, it's standard to use a grounding system on electrical circuits. This means that the system is connected to at least 3 wires. There's the hot and neutral, which allow the electricity to flow through the circuit. The third wire, or the green wire, goes to ground. Ground means ground. In some European countries, they call it earth or earthing. In most buildings, the electrical system uses a copper ground rod that is driven into the earth or ground. The purpose of this grounding device is to allow electricity to flow to ground in case of a circuit malfunction or short. If the ground wire anywhere along the circuit is open, electricity won't flow through the ground wire. It will flow through the next path of least resistance, the person's body. The moral of the story is that someone should test the grounding wire throughout the entire electrical system to make sure the circuit is complete and there are no broken wires or other open circuitry. Let's begin with extension cords. They are very useful and serve a good purpose. However, when used improperly, they can lead to injuries. Using a grounding adapter on an older electrical outlet is not allowed in the workplace. What happens here is you have a 2-prong electrical receptacle, but you need to insert a 3-prong plug. In this case, 3 does not fit into 2, so a logical choice is to find an adapter. Couple of things wrong here. First, the receptacle is not grounded, or it may be grounded by metal conduit, not a 3rd wire. Next, you're relying upon someone to connect a grounding wire on the 3-prong adapter to the metal screw of the receptacle. Supposedly, this provides adequate grounding, but in 90% of the cases, it does not. If you connect this grounding wire to the electrical receptacle, you're assuming the receptacle metal case is connected to ground by conduit or metal pipe. In many cases, the conduit does not make a complete circuit to ground, so you do not have any electrical ground protection on this circuit. It does nothing but provide a false sense of security. Of course, do not use extra plugs to extend electrical outlets. These are also referred to as octopus plugs. Many bad things occur when you overload circuits, so use the proper rated electrical cord or circuit for the tool or appliance that you're using. Never run electrical cords under carpets or rugs. Although this may reduce the tripping hazard, the cord could become worn, or if it overheats, it could become a fire hazard. When you want to remove an electrical plug from an outlet, always grab the plug and remove the plug. If you hold the cord and pull, you could be dislodging the wire from the plug, which eventually may cause a short or fire. Remove plugs by gripping the plug, not the wiring or cord. If an electrical cord is cracked, frayed, or cut, It should be replaced. The practice of using electrical tape to repair the cut or defective cord is illegal and should never be used. Don't repair, replace. Electrical equipment can be repaired, but only by qualified repair and maintenance personnel. Defective electrical cord should be replaced. Double insulation means there's insulation inside an electrical tool that is designed to provide a degree of protection to someone using that tool, and there's a short or malfunction of the equipment. Double insulated electrical tools are operated with only a two-wire connection. In other words, there is no circuit ground on the tool or in the wiring or cord. A two-prong plug and two-wire conductor allow electricity to flow to the tool. Both the double insulated and grounded tool are designed to protect the user in case of a malfunction or electrical short. A grounded plug protects the user by providing a safe path to ground for an electrical fault. A double insulated tool provides the same protection, except in a different way. Any exposed metal pieces are separated from the motor and the other electrical components by two layers of insulation, such as mylar-backed paper or a single layer of specially engineered dielectric plastic. So any electrical malfunctions are contained within the tool, and the tool's user does not become the path to ground. If you see an electrical tool with a two-prong plug, the first thing to do is inspect the manufacturer's label on the tool to make sure it says double insulated. If it doesn't state double insulated, then the tool must have the grounded electrical protection system and the three-prong plug. If you see an arc when unplugging an electrical appliance, breaking the flow of current at the plug causes it. Turning the appliance off prior to unplugging can prevent it. Avoid using phones and faxes or computers during electrical storms. Make sure they are unplugged. Always inspect your electrical tools and equipment before using them, and never use any defective electrical equipment. If the tool or equipment gives you a shock or slight tingle, shut off the equipment and report it immediately because something is wrong with the equipment and it needs repair. All electrical equipment should have an authorized label or mark on it to certify it meets applicable standards. The UL, or Underwriters Laboratory, is a testing agency that issues their seal of approval on most electrical equipment that is manufactured. As a quick review, let's take a look at some very basic electrical safety tips. There are a few tips we didn't include in the training program. Water and electricity don't mix. Moisture on your hands and electricity don't mix. Don't use a metal ladder for any type of electrical work. The same applies to construction personnel who use metal tape devices. Stay away from electrical energy sources. Always inspect your electrical equipment before using it. Don't assume the electricity is off. Test the circuit before working on any electrical line or circuit. Watch for power lines. Many people have been electrocuted by hitting power lines with metal ladders, antennas, and other conductors. If you must work near power lines, make sure you stay at least 10 feet away from any energized power lines. For higher voltages, 10 feet may not be a safe distance. If your electrical equipment requires grounding, don't use it unless the ground wire and ground prong are connected. Never use any tool or power cord with the ground prong broken or missing. If you're not an electrician, don't try to make electrical repairs. Use only UL-approved electrical equipment. Don't use extension cords that are rated at a lower capacity than the equipment you're attaching to the extension cord. Don't use indoor extension cords outside, particularly in inclement weather. Don't use octopus plugs to extend the number of appliances or tools on any one receptacle. Unplug all heating appliances after you use them. Never replace fuses or circuit breakers with a higher rated one than its rated maximum. Inspect fuses and circuit breakers periodically, and if any of these devices appear to be hot or heated, it's time to have an electrician test or replace them. We sincerely appreciate your attention to the program and wish you continued success in your jobs. Don't forget to take electrical safety home with you, because there are as many deaths in the home as there are in the workplace. Thanks for participating.